Hi, my name's Andy Young. I'm one of the lecturers down at Unitec in Auckland, and I'm producing some videos which cover the various workshop tasks that we need to do on campus with our students. And I see no reason why I can't share these videos with you on YouTube. So welcome. We've just finished doing some tests on the alternator itself, on this charging system. And the alternator passed with flying colours. We did an OCV test on the battery prior to that, and the battery itself was of reasonable state of charge, which it needs to be to do these tests. So now, in this video, I would like to do the second part of the on-car testing, which is to test the remaining circuit, the wiring, that gets the current and the voltage produced by the alternator to the battery, to charge the battery up. Now, the alternator does two jobs. It produces a charge for the battery to top that up for once you've started the engine, and if you've had ancillaries on and depleted the state of charge of the battery. But whilst the engine's running like it is now, the alternator is what produces the current to run all the systems on the car. If we exceed the maximum output of the alternator, or if the alternator fails or its output becomes less than what it should be, then it's the battery's job to step in and top up and give us the sufficient amperage that we need to run all the systems. Now the problem is, when the battery does that, the battery over time will, just like a water reservoir, will slowly get more and more depleted to a point where if nothing changes, at some point in the future, be it half an hour if you've got lots of ancillaries on, or it could be a few days if you don't really use much, if you just drive during the day, the battery will go flat. And flat will mean basically it has insufficient charge to start the engine the next time you come to use the car. Now, many people assume that when the car doesn't start, it has a flat battery, it cranks very slowly, it doesn't fire. They assume the battery is at fault. And quite common, the battery isn't at fault. However, they'll go out and they'll buy a new battery, install it, and the car obviously will start because the battery's come charged. But again, further down the line, they're going to have the same problem again. The battery's going to go flat, and it's at that point that then go to a garage and get them to check everything out. These tests that I've been doing are extremely simple. All you need, essentially, is a multimeter. These are available from any good outlets. This one's from Repco, but lots of places sell them. JB Hi-Fi and Dick Smiths and all those kind of places sell them. Don't be tempted to go for the cheapest possible. You can get them for like $15 now, but they really are, well, they're rubbish, to be honest. You want to just spend a little bit more. This was about $50, $60, and it's good enough for me. It's got lots of different functions on there that I need to use for other tests. For this particular test, all you guys need is a multimeter that's got DC volts between 10 and 20 volts, and they pretty much all have that. So, I'm going to run through now how to do a volt drop test, and this will give us an indication of any problems within the wiring between the alternator and the battery. And it really is quite simple. I'll leave that up there. Okay, I've put little crocodile clips on mine just to make it a bit easier because I'm having to present at the same time. With these, we've got the positive one, which is that one there. And again, we can clip that onto the output of the alternator. Now, the output of the alternator is the thickest wire. It's used on a single bolt, a stud essentially, which is normally a 10mm spanner size. So we clip that on. I'm going to put the negative lead of the multimeter onto the positive terminal of the battery. Let's see what happens. Okay, so we get a reading, and essentially we're reading the difference in voltage. So we've got 0.17. So there is a 0.17 volt drop between, or along this wire, from where it comes out of the alternator to where it gets to the battery. So we're losing almost 0.2 of a volt to the battery. Now, that's within spec, but only just, actually. If that was half a volt or 1 volt or 1.5 volts, then that is a significant volt drop, and there would no doubt be a problem or a number of problems along that circuit. Could be corrosion right at the start, where the wires connected to the terminal at the end, where it's crimped. It could be all corroded, and the wiring, the copper wiring can rot. Or it could be somewhere in the loom, and all you can do is follow it around and keep measuring the volt drop. Just keep going into the wiring and measuring the volt drop, and you'll find a point where it would suddenly drop down, and that's where your point of high resistance is, and that's where you're going to get your volt drop. Now, if you've got a large volt drop in the circuit, it doesn't matter how good your alternator is, you're not going to be getting the full output to the battery, which means the battery's not going to be charging up as well as it should do. So we've just tested very easily the positive side of the circuit for the alternator. That's the output wire to the battery positive, and we got essentially 0.17, nearly 0.2 of a volt drop, which is okay, but only just. Any higher than that, and I'd be starting to pull things apart and have a little look. Don't forget, this is a reasonably old car, so I'm not too concerned. If it was a new car, then we've got a bit of an issue. Just one thing to mention: these volt drop tests have to be done with the engine running, and they also have to be done with the alternator under load. And I've got the headlights turned on, I've got the interior fan blowing away, I've got the rear window demist element energized, and every now and again, because the engine's running, we've also got the cooling fan for the radiator firing up. And that in itself uses about 10 or 15 amps. So we need to load up the system to be able to highlight these volt drops. Okay, so we've just finished testing the positive side of the circuit for the charging system. We're now going to test the negative side of the circuit, because we've got to test the whole circuit, otherwise it's pointless. And to do that, it's quite simple. We put the negative lead of the multimeter onto the casing of the alternator. The other lead, the positive lead of the multimeter, all we need to do now is clip that onto the negative of the battery. There we go. And we're getting a reading of, you can see that okay on the screen, there you go, look, 0.09. So near as damn it, 0.1 of a volt drop. So we've now tested the whole system. We've got almost 0.2 a volt drop on the positive circuit of the system and 0.1 volt drop on the negative. So in total we've got 0.3 volts being lost in the wiring between the alternator and the battery. And that's nearly a third of a volt. That's right on the edge of being acceptable. If it got up to half a volt, anything above that, then I would want to start looking at each individual component. We've got the highest drop on the positive side, and that's because mainly the positive circuit is a much longer routed wire, and the longer a piece of wire is, the more resistance it has, and the more of a volt drop you're going to get. So that's expected, but anything more than sort of 0.3 of a volt in total, then I'll be looking further. So on this particular vehicle, the charging circuit is great. No problems at all with the wiring. It's all within spec. It's acceptable. It's not a brand new car at the end of the day. We've checked on a previous video the output from the alternator. We've checked it both using the voltmeter and a clamp type ammeter, and we tested that under load, and we got up to 70 amps output, which is excellent for an alternator this size. And we did an OCV test on the battery to check the battery's state of charge. We need to have a battery that's at least half charged to be able to do these tests on the vehicle. If the battery's flat, forget it. You can't do these tests. You've got to take the battery off the vehicle, go and charge it up, get it charged, put it back in, and then run your tests. Okay, well, I think we're about there actually. The next video is going to be more into testing batteries, and if you do a search, Andy Mechanic, battery test, then you'll find the video. Okay, well, my name is Andy Young, and I work for Unitec as an automotive lecturer. Unitec is based in Auckland, New Zealand, and these videos are done to help my students through the year. Then we do workshop tasks pretty much every single day. This is just one of the very many workshop tasks that we do, and I'm hoping that doing these videos is going to really help them to improve their learning. As I'm one of the e-learning champions at Unitec, I think producing videos is essential to transposing our course to online. Not only online, we do a lot of hands-on stuff as well, but the benefit is you can watch this video over and over again, and so you actually understand what I'm talking about. Hopefully it's of some help to you. Thank you very much. Cheers for watching.